In this video, I'm going to solve this problem Speedrun, which is held in Starters 137 on June 5th. So let's jump into this video. Initially, I'll make you understand the problem statement, and later I'll make you understand the solution, how to approach this problem. So basically, it says that Chef is playing a computer game where there are n monsters on the number line, and Chef is at a position 0 on the number line, and ith monster has a health equal to hi and is at a position ai. So, and it is guaranteed that ai is less than or equal to ai plus 1 for every I to 1 to n. So, basically, let us first check whether ai is positive or not. Yeah, it says that AI comes from 1 to 10 power line, and health is also is positive range. So basically, it says that if we have a number line here and there is no negative axis concept here, there is only positive axis concept. So chef is at a position at the origin. Chef is here, and there are monsters at a position at the positive index anywhere, like the position are given by A, denoted by A1, A2, A3, and sorry for the bad handwriting, A1, A2, A3, and each of them has an health H, H, I, H1, H2, H3, and go on. It goes on. Like there are n monsters, so n monster, all of the n monsters are all in the positive x-axis, and Jeff is at a position 0. So in the next statement, it says that says that for every second the following thing happens every second, and Jeff can choose a single index I, and such that ith monster is still alive, ith monster is still alive, sorry, ith monster is still alive every second, and it can fire one bullet at it, and this reduces the health of the ith monster by one. And it says that after doing this thing, the following two things happens, this and this, and it says that all the ally monster whose health 0 will die, and which means the monster he has the got hit by the bullet, the one like monster can be hit by only one bullet can't pierce through all the monsters, right? It doesn't states like that. It says that the one bullet will hit the one monster, which is the ith monster, and if that monster health will be reduced by one. If it becomes 0, it will die. And it says that all the ally monsters move one position closer to the chef. So after hitting the bullet, whether that monster is alive or not, and whether the other monsters is alive or not, it doesn't matter. But they will be moving one step closer to the chef. So basically, in the number line, chef is there here, and monster is at a position 1, 2, and 3. If you choose the monster position at 2 to be fired by the bullet, then health will be reduced. Hey, let's say it has some health H, uh, sorry, some health H, and it will be reduced by 1. And if it becomes 0, it will die, or if it is not, the monster, whether it dies or not, the monster present it at the position 1, 2, and 3 all will be moving one step closer to the chef. Yeah, that's what it says, right? Let us understand once again. Chef can choose a single index, and the ith monster is still alive. They fires one bullet at it, it reduced by one, and all the alive monster whose health is 0 will die. It doesn't mean that the bullet will be hit for the all the monster. It bullet hits only for the ith monster, and finally, if all the monster move one position closer to the chef. So, and it also says that if any monster reaches the position 0, chef loses. Obviously, the monster reaches at the chef position, the chef has to die. And if the chef manages to kill all the monsters before any of them reaches the position 0, and then chef wins. So we need to find whether the chef is winning or not. And if you look at this next statement, it says that before the start of the game, the chef can plant a bomb at any position on the number line. If the bomb is placed at a position X, then all the monster whose starting position is between X minus K and X plus K will die immediately, x minus k and x plus k will die immediately, and the game will start with the remaining monsters. So basically, it says that, and let me just confirm what is k, and it says that k is the range of the bomb. Okay, k is the range of the bomb. See, the chef can place a bomb at a position, some any position on the number line, but bomb will be working at that position minus k and that position plus k, and all the monster lying in that range will be dying immediately. So we actually, the actual question is, we need to place the bomb at such a position, and so that chef will be winning the game. So that's the problem. Let me get into the input parameters. First is test case T, and followed by the next line is N and K, where the N is the number of monsters and K is the range of the bomb. And next line is the position of the monsters, A1, A2, A3, so until AN. And next line is, and the health of the monsters, H1, H2, H3, so until HN. So it goes like this, and we need to find whether in this whether the chef will be winning or not, and such that after placing the bomb optimally. So see, now our actual problem is we need to place the bomb optimally, and if you look at this part, the firing the bullet and all, it happens on its own. Like, our main concern should be placing the bomb optimally such that none of the monster will be reaching the chef. This will happen at the end. Like, you don't need to worry about the firing the bullet. If you kill the monsters with the bomb itself, it's fine. It's well and good. So let me get into the solution part. So basically, as I said, we need to find a place to, so that bomb can be placed such that the monsters will be killed, and we can't place in any random position. We need to place such a way that, the we need to find a monster that will reach the chef, that very first monster which will reach the chef. I'm not talking about, let's say, this is the number line, and a chef is at position here and monsters are here, and each has a health a, and sorry, position, it is each one is at a position a, and with health h, and it doesn't mean that none of the monsters will be reaching that position of the chef even after firing the bullet. See, if they didn't say that h cannot be less than a, so if h is greater than a, even after firing the bullet, like, chef chooses this monster to be fired, like, at each and every time, even after firing the bullet, health will be reduced by one, but it will be moving closer to the chef, right? This distance, it is a, but the actual distance the monster can be moving is hi until it is alive. So if h is greater than a, obviously the monster can cross this origin and chef will die. So and so it's, and it doesn't mean that the h can be greater than a not for the first monster. H can be greater than a even for this third monster as well, not for the, like, let's say h is less than a for the first monster, h is less than a for the second monster, and h is greater than a for the third monster, and we need to place the bomb on the third monster, not on this first monster. We need to place the bomb on the first monster which will be reaching the chef, not the first monster on the number line. So first monster which will be reaching the chef, that condition will be if the health is greater than the position it is currently present, then the monster will be reaching the chef. So that's what we need to find, and after finding that position, the bomb will be working in the range x minus k, and x plus k, right? Bomb will be working in this position x minus k and x plus k. So let's say which is, well, let's say I'm placing the bomb at the position here, and I, after finding this position of the monster, and I am, like, I am sure that the monster which are present before this thing won't be reaching the chef even after firing bullet. Why? Because H was less than A. So the monsters after the monster which will be reaching the chef, as the danger of the monster which will be reaching the chef, like there can be many more monsters which can be reaching the chef after this monster, right? So we need to place the bomb in such a way that it should be killing the very first monster which will be reaching the chef, and also the other monster which will be reaching the chef. Like we should be killing as many monsters which will be reaching the chef as well as the first monster which will be reaching the chef, and after that it is up to the fate whether the bullet will be killing them or not. So till where we can place the bomb such that this monster is also killed as well as it will be killing all the monster is depends on this range x minus k and x plus k. If you see that the maximum range it can go up to is 2k plus 1. Like if you see this difference is 2k plus 1, so maximum range it can go up to that. It is like a sliding window. So just find the place like till this position a I to 2k plus 1 times ai, the till that position 2k plus 1 plus ai till that position how many monsters are killed in each and every position, and you define the maximum most position the number of monsters are killed such that this is also killed as well as the many more monster which will be reaching the chef, that the possibility is also eliminated. After doing that, that's all, the job is done. And only thing is that you need to check even after placing the bomb whether there are monsters which will be reaching the chef such that H is greater than A. So if it is monsters are like that, then no, chef won't be winning. Print it no. If there are no monsters such like that, then chef will be winning. Then print it yes. That's it. Thanks for watching this video. Thank you. Bye.